Now that you've seen what the quadratic equation is or what the quadratic formula is from my previous video and when to use it, I'm going to go ahead and now go through some examples of me actually working out problems using the quadratic formula. So if I look at example 1 here, the first thing I want to point out about example 1 is that I wouldn't typically choose to use the quadratic formula to solve it. The reason being is I can see that 5 times 5 gives me 25 and 5 plus 5 gives me 10. So I could factor this to be x plus 5 times x plus 5 equals 0 and then use my zero product property. However, I did want to choose a beginning equation to be a little bit on the more simple side, so that is why I chose one that, as we can see, it can be factored. So typically I would factor this, but just to show I can use the quadratic formula to solve it, I'm going to go ahead and take my quadratic formula, which I know is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, looking at my equation, I do need to determine first what my a, b, and c are. So, I'm going to go ahead and say that a is the coefficient on my x squared, or my quadratic term, which is 1. B is the coefficient on my linear term, which is 10. C is my constant, which is 25. I'm going to go ahead and plug each of those in to my quadratic equation. When I do that, I now have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I do want to apologize since I did not mention in the beginning of the video, you will need a calculator or a pencil and paper at some point where you can work these out, and you can just work them out right in your notes, so you don't necessarily need a separate sheet or a separate piece of paper to do it, but a calculator is handy when doing these calculations. However, most of them can be done just with scratch paper. So now I'm left with, back to my original problem, negative 10 plus or minus the square root. I know that 10 squared is 100. Sign belongs to the number, so I'm going to go ahead and say negative 4 times 1 is negative 4 times 25 is negative 100. You can also drop the minus sign down and go ahead and do 4 times 1 times 25. It will not change your result. All over 2 times 1, which is 2. Working, notice I'm just doing order of operations, so working within my radical, I now have negative 10 plus or minus the square root of 0 all over 2. The square root of 0 is just 0, so moving up here as I run out of room. This is going to leave me then with negative 10 plus or minus nothing, so I do not need to read it. Negative 10 over 2 then gives me an x value of negative 5. So I have solved the quadratic equation. So notice that this did only have one solution. My one solution was x equals negative 5. Remember that my solutions to quadratic equations do stand for my x-intercepts. So if I were to look at the graph of this, what I would see is that my vertex is going to touch the x-axis, or the x-axis at one location, and it will happen to be at that x equals negative 5. And that is something we can look at tomorrow in class in our graphing calculator as well. Moving along now to example 2, because I have ran out of room here, I'm going to grab a new slide and rewrite that example out. So example 2 was solve the quadratic equation (3x squared plus 2x minus 1 equals 0. So if I wanted to solve this, I noticed that I would not want to factor this, because if I did factor it, I would need to go through that long process, and I may even go through that long process and still find out that it's not factorable anyway. So rather than take the time to go through that process, I'm going to go ahead and right away I'm going to say I will use the quadratic equation on this, or the quadratic formula on this, because of this 3. Again, my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, first going ahead and looking at my equation and determining what my a, b, and c are, I see that a is again going to be the coefficient on my quadratic term, so I get a equals 3. B will be the coefficient on my linear term, so b equals 2. C will be the coefficient, or excuse me, will be my constant, which is -1. Working from here, I then get x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Using order of operations to clean up what I have underneath my radical, -2 plus or minus the square root. 2 squared is 4. Be careful here, I see people miss this all the time. If I think about signs belonging to numbers, notice this is a -4 and there is a -1 here. So if I have a negative times a positive times a negative, this is all going to have to become a positive number here. So remembering that, -4 times 3 is -12, times -1 is a positive 12, all over 6. Simplifying that 4 plus 12 further, I get x equals -2 plus or minus the square root of 16 all over 6. Again, I'm running out of room, so I'm going to finish the problem up here. I do know what the square root of 16 is. When we are working with the quadratic formula, oftentimes students will ask me when they should stop. If you can do it, do the math. So then I get -2 plus or minus 4 all over 6. So now this breaks into two separate problems that I need to work out. So I now have -2 plus 4 over 6, which will be one of my solutions, and -2 minus 4 over 6, which will be my other solution. So -2 plus 4 is going to give me 2 over 6, which reduces to 1/3. -2 minus 4 is going to give me -6 over 6, which reduces to -1. So again, when looking at my original quadratic equation up here, I do see I get my two solutions of x equals 1/3, x equals -1, which again are going to be my x-intercepts. Moving on to the third example. If I now look at example 3, the first thing I notice about example 3 is with this -1 over here, I am not in standard form. So the very first thing I'm going to do before I decide which method to use to solve it is going to be to add 1 to each side to make sure that I am in standard form, giving me 2x squared plus 6x plus 1 equals 0. Again, notice I don't want to try to factor this because of this 2. I know that if I did try to factor it, I would have to go through that long factoring method. And because there is no guarantee that even after going through that long method that it is even going to be factorable, I don't want to put myself through all that work. So I'm going to go ahead and choose to solve this using the quadratic formula, which is, remember, x equals -b plus or minus the square root b squared minus 4ac all over 2a. I'm going to anticipate the fact that I'm not going to have room to do this example 4 on this page, so I am going to go ahead and cross that out of here for right now and use this space to help me solve this one. Next, I'm going to define my a, b, and c, a being my coefficient of my x squared term, or 2, b equaling my coefficient of my linear term, so 6, and c being my constant of 1. Using these to then fill in Using these to then fill in for a, b, and c in my quadratic formula, I do now have the formula looking like x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, cleaning up just using order of operations, that then gives me -6 plus or minus the square root of 36 minus 4 times 2 is 8 times 1 is still a -8 all over 4. Again, coming up here because I am running out of room, that gives me -6 plus or minus the square root of 28 over 4. Remember we talked about in class or online that we can go ahead and say whenever we have a square root that contains a perfect square under it, we can simplify that by taking that perfect square out. So I know that 28 can be divided by 6, so I will rewrite this as -6 plus or minus the square root of 4 times the square root of 7 all over 2, which then simplifies to -6 plus or minus 2 times the square root of 7 all over 4. Now remember, I could not reduce if this term here and this term here were the only two divisible by 4, or likewise if this term and this term were the only two divisible by 4. But because all three of these terms are divisible by 2, I can divide every single term by 2. It is a form of factoring. We can look a little bit more depth on that and the reason why in class, but for now I'm going to go ahead and just know that 6, 2, and 4 can all be divided by 2, so I am going to take that common factor of 2 out of each of them, leaving me with a final answer of -3 plus or minus the square root of 1 times 7, or just the square root of 7, all over 2. Because I do not know what the square root of 7 is, I'm going to go ahead and leave this as my final answer in exact form. I could use my calculator to approximate what my two solutions are, one of them being -3 plus the square root of 7 all over 2, the other one being -3 minus the square root of 7 over 2, but I am going to go ahead and leave it in my exact form. Moving on to my fourth example, at this point here I would like you to try to pause the video and solve. First write this down, then pause the video and see if you can't solve this equation for x. Okay, so now that you've had a chance to try it, I'm going to go ahead and solve it. We'll see if you were able to get the same answer as me. I do first need to get it into standard form, so I will start by subtracting 36 from each side, giving me x squared plus 12x minus 36 equals 0. I know that if I try to factor this, because of this x squared and it being a trinomial, my first instinct would be to try to do factors of -36 with a sum of 12. As I try to do that, as I try to pick different numbers that multiply to give me -6 and add to give me 12, I notice that I can't find any. So I know that I cannot do it by solving, or excuse me, by factoring. So because I could not use factoring, my next try is going to be to use the quadratic formula, which again is x equals -b plus or minus the square root b squared minus 4ac all over 2a. Notice that for this equation, my a is 1, my b is 12, and my c is -36. So I'm going to go ahead and plug each of those into my quadratic equation, or my quadratic formula, and I get x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Order of operations tells me to work inside of the radical first, so I do get -12 plus or minus the square root of 144. Minus 4 times 1 is -4, times minus 36 is a positive 144. Again, be careful because it is a common mistake I see that -4 and -36, minus times positive times minus, does have to come up with a positive. All over 2, which gives me -12 plus or minus the square root of 288 all over 2. So I see that 288 has some perfect squares in it. So if I check on my calculator, my first instinct is to usually try to divide by 16. So I notice that when I try to divide 288 by 16, it does become -12 plus or minus the square root of 16 times the square root of 18 all over 2, which is a really good start. But I know that 18 still has another perfect square in it. I can break this square root of 18 further by saying square root of 2 times square root of 9. So I'm going to say that this is now -12 plus or minus 4, square root of 16 becomes 4, times the square root of 9 times the square root of 2 all over 2. From here, I then know that the square root of 9 is 3. Because these two here are written right next to each other, I know they are being multiplied. So I now have -12 plus or minus 4 times 3 times the square root of 2 all over 2. I've ran out of room here, so I apologize. But please do notice that -12 this 12 here, and this 2 can all be divided by 2. So I could take this a step further, and again, I apologize for putting it up here. Let me see if I can change my pen color, if that helps a little bit. If I brought it up here, that would, again, dividing each of those 3 terms by 2, give me -6 plus or minus 6 times the square root of 2. I could say all over 1. I do not have to say all over 1. I can leave it like this. This is going to be my most simplified exact form. Again, I could use my calculator to approximate it, but I'm just going to leave it in my exact form, which is how we will leave most of our answers when we're working with quadratic equations in class.